One of the biggest AI companies, Anthropic, their CEO just said by next year, he thinks that AI models will be able to survive and replicate in the wild. New video went viral of a robot working for 20 hours straight and then collapsing from exhaustion or lack of power. Not sure how to think about it. So OpenAI's GPT-4, the large language model, can now read security vulnerability memos, which are for people to protect themselves to then exploit better. Sakana AI is getting these amazing text-to-image models by essentially breeding a bunch of other models together, and whichever one's best make it to the next generation. Super disruptive AI hardware generation company Groq is getting a blistering 800 tokens per second on the new open source Meta Llama 3 model. Putting AI on a smartwatch is now helping it predict arterial fibrillation 30 minutes before it happens. A new AI model can go from language to motion. AI can now surpass humans in almost all performance benchmarks. Over at Google Deepmind, possibly after playing with Claude, are getting a little bit scared. But first, let's go check out the AGI countdown. Still at 72% of the way to AGI. So Dario Amodei is this guy. He is the CEO of Anthropic. They're super well funded. They build frontier models. And he just laid out some pretty intense ideas about the future of artificial intelligence.
There's a substantial increase in risk as would be evaluated by, say, the national security community, where we would worry that North Korea or China or Russia could greatly enhance their offensive capabilities in various military areas with AI in a way that would give them a substantial advantage at the geopolitical level.
So he compares the state of AI to a place where autonomy and persuasion are just around the corner. The big quote that's really standing out and getting people talking is this: various measures of these models are pretty close to being able to replicate and survive in the wild. I mean, bro, that's cat out of the bag. That's never going back in. That's a different world. That's an alien species.
And on the autonomy side, it's various measures of like, these models are pretty close to being able to, replicate and survive in the wild. So it feels maybe one step short of models that would, I think, raise truly existential questions.
So impressed for a real timeline. He's like, they'll replicate and survive in the wild anywhere from 2025 to 2028. He says right here, quote, "I'm truly talking about the near future here. I'm not talking about 50 years away." And I hear more like realistic conversations coming out of Claude than anywhere else. It is crazy. So if you haven't seen this robot warehouse worker named Digit, we covered him probably like almost 9 months ago now, I would say it was the first time, but we've seen him a few times out of Agility Robotics, and a lot of times he's at these trade shows demoing just how well he can work in the warehouse. But after a grueling 20-hour shift entertaining people with his work ability, he kinda collapsed. Ooh. Who hasn't had a toy run out of power like you, Grimlock, unable to charge if you're ever wondering why he's not working? They run out of power, why don't they just beep and fold up carefully? And of course, the usual debate in the comments, just please don't get emotionally attached to robots, they're just machines. Then right after this, the next comment is like, this makes me cry at how effed up our society is and how disconnected from life most people are. All right, so on the security front, large language models are great at reading large amounts of text, but guess what usually comes in a large amount of text? How people should protect themselves from vulnerabilities. And in the forever chicken or egg problem we're about to be dealing with the rest of our lives, GPT-4 can actually read all of this and quickly give people the actionables they need, or maybe in the future even code the patches itself. But also, it can read that and then exploit those vulnerabilities. So in this paper, some university students decided to give GPT-4 some descriptions of 15 computer vulnerabilities. And it managed to exploit a whopping 87% of them. All right, well, that's way better than other older models. And in case you're budget-minded, it turns out that when you divide how much money it costs to run the LLMs and come up with the attack vectors, the figure was $8.87 per exploit. Now it's time to talk about Sakana AI, and I wouldn't be surprised if you're not familiar with this because this whole project is pretty much in Japanese. But it's so crazy because I remember thinking, we're going to enter a future where there's all these agents out there and they're going to kind of like mix together and interbreed to become better and better. And that's exactly what this startup has done. And it does improve the images that you get when it's survival of the fittest and they're mix and match models. So let me break it down for you. Thanks to a little Google Translate, we go from Japanese to English. And then we learn about this, Evo SDXL-JP. Japanese prompt is what that JP is for. And it is an evolutionary model that mixes different diffusion models together to make ever better text to images. Okay, so one of the weird things about AI is everything can be merged so quickly. I mean, human brains, we have to talk to one another or type it out, and there is elements on the internet of how ideas can sort of converge and people can learn from one another, but there's something different about how fast we might see the evolution process happen. And this is what I mean. The existing models are sort of understood to be like better at some things and worse at others. So we start there. And then similar to natural selection, these models are evaluated based on a set of performance criteria for the desired outcome. So the best performing images move on to the next round, but they're not just individual models. This is where they start crossbreeding. So the key step here that this company's doing that I haven't heard of anyone else really doing before, even though I know this is like kind of part of our AI future, they just randomly mix together two models' different architecture or their parameter counts or some combination of these variants, and then they just see what kind of image it produces. So layers, weights, features, they're all mixing and matching on each generation. And then guess what else they're doing that they learned from Mother Nature? They're adding random mutations once in a while. Yeah, I'm not kidding. So to further enhance model innovation and adaptability, mutations are introduced into the models. It's just really an interesting approach. I guess I should have mentioned at the beginning, but the overall goal of this company is to get images to be more culturally nuanced for almost the individuals or at least small communities. So, I mean, that's why it's got to look culturally close, because communities break down to pretty small, like almost block by block in a lot of cities, and they have their own feel and vibe, and you just go a few blocks over and it's a different feel and vibe. Like, they want images that are that specific. And if this evolutionary process is happening and we all have our own branch and each community is generating images and somehow it understands that, it's going to kind of naturally percolate in a way where you don't want to actually have somebody building and tuning parameters for certain things. Like it just naturally gets in. All right, but moving on, let's talk about the big Llama 3 model that came out that I talked about in the last video is now running in lots of places because it's open source. And when it's on this Groq AI chip, it is achieving a blistering 800 tokens per second. Check out Meta's model. 3, 2, 1, done. And you know what, if we can actually at that speed go from voice to text, have it processed by something like Llama 3, and then back into text to voice, you could actually probably have a real-time phone call with someone and not know that you're talking to an AI. So be careful, be aware that might kind of be on the horizon here. All right, let's talk about AFib. So this is a heart arrhythmia problem. So you sometimes have the top part of the chamber of the heart beating differently than the bottom, and it gets kind of out of whack, and sometimes it speeds up to try to like correct, and it just feels very scary. Now, some of the best technology we have can only predict this about 30 seconds to a minute before it happens, but there is a new artificial intelligence that by taking these samples throughout the day seems to know with pretty high accuracy almost 30 minutes before something like that happens. And it's the kind of technology that could be implemented into a smartwatch really soon. I just thought this was a really cool use case for artificial intelligence, and also if the system itself can be tuned on your own heart problems or your heart patterns, then when you actually do have one of these kind of outbursts where you feel the rhythm get way out of whack and you're kind of tighten up, and all of that stuff happens with the history of what happened before it recorded, these systems are going to become even better at knowing you and your patterns and may be able to tell you much further, what, hours, days, even months maybe, where you can actually do like a lot to change your health. That'd be great to know about. Obviously reasons why we want to talk to, in the future, a robot, but for now, a virtual character, and say to them, can you go over here? Will you lie down? Will you like spin around and dance? Will you go move that box? And have the character understand the right movements, the movements that would be natural to a human in that same environment. So we're talking about going from a language prompt to body motion, like an action. So these researchers came up with this kind of new way to train a model. They're calling it scene affordance. And you can think about it like in a scene, like understanding the environment and what the scene should be. Like you could imagine an actor actually that's on a stage. They would just know how people are acting, and even if they went off cue, they would say, oh, I'm in 17th century Europe and I'm dressed a certain way, and the proper way to handle this sort of a change would be something along the lines of this. This is the same thing. It's a middleman, like an AI that's supposed to figure out the human movement from the scene. And it's notable because it's not about just moving something or how to move a knee or even how to walk or fall properly. It's about learning that when you're excited in a certain way, that you can be excited and there's certain things that need to change depending on if you're sitting or lying down or on your knees. When you're tired or frustrated, you flop over, but you can flop over differently, but still kind of in a way that makes the most sense for the situation. And I think we'll see something really cool coming out of this. In fact, on a previous video, we've talked about the Disney pipeline to make those really cool animated characters where they're mostly doing things with artificial intelligence and animation, like exaggerated movements, especially on robots that are not very human-like. They have exaggerated articulation and exaggerated body shapes, because this will probably eventually make its way into like the Disneyland parks being like characters like Mickey Mouse and whatnot. But something like that, along with this middleman that understands the scene, seems like it would be a very powerful combo to me. So yeah, if any Disney Imagineers are watching, just heads up there. Okay, so now let's talk about this article. AI is now surpassing humans in almost all performance benchmarks. So to preface this, if you think about where artificial intelligence was a decade ago, 5 years ago, 2 years ago to now, you really see how we've continually pushed the goalposts back and been like, if it can play chess, it's AI. Oh, it can play chess. That's not real. That's just like a search tree. Oh, it can play Go now. That's just Go. That's not really it. Oh, it can fold proteins. It can play games. Large language models sound pretty human, but they fib a lot. They're kind of hallucinating. And just like take a step back and think of how far we've moved the goalpost. Like, this is crazy that most things it does better than humans. All right, so they adjusted this graph so that everything's based on where humans are, right? So this human dotted line here, whenever these lines cross that path, they have made it to about or better where humans are. So think about it. As of today, we can do image classification. You can put a bunch of objects in photographs and send them to neural networks, and they can say, oh, that's a cat, and that's a dog, that's a whatever. Even better than human baselines. Visual common reasoning is above humans. Natural language is above humans. And even the couple that really haven't got to where humans are, they're like almost straight lines up. Like, of course they're going to get there next year. Multitask language understanding, reading comprehension, visual reasoning, English language understanding, basic level reading comprehension, competition, mathematics. This is the same Midjourney prompt for the last couple years. A hyper-realistic image of Harry Potter. Back then, I remember, I think it was just Stable Diffusion. I don't even really know of Midjourney when I first started making this YouTube channel, and I was laughing at all of these images. They were goofy, but they were still fascinating. But February 2022, that's the best Harry Potter. By April, July, November, we're still in 22. It's looking pretty good. And then in 2023, we get so much more detail. And now we're seeing the same thing with video, where like this kind of first half is almost what you've seen come out of Pika Labs and Runway ML, and you're starting to see the beginning of Sora, where things are starting to look like this second 2023 generation of images. And that might very well be part of why those smart folks over at Google DeepMind are calling for limits on AI that mimics humans. Okay, so here's the deal. As we move from something that's just kind of text-based like ChatGPT into something that's multimodal, where you're just picking up your phone, you're pressing an earpiece, something like in the movie Her, where you're just like talking all day long to something, we're going to start getting lost in it. So they say that the ability to communicate with AI in natural language and its tendency to imitate human behavior could lead users to form inappropriate close bonds with these assistants. Yeah, I think they're kind of right. I mean, I think it's going to be really easy for us to, as they say, like result in disorientation and a loss of autonomy. That's another thing, giving up your choices, because so many times ChatGPT is like, this is a good thing to do. And I'm like, you're super smart. I should probably listen to you. Like, imagine when we just like give up autonomy and we're like, you're the leader now. Now, where should I go for a restaurant? What should I say to this girl? What should I do today? At a certain point, you're going to just want to be like, I'm just going to go do something stupid because I'm not as smart as you and I just want to be in control of something. But that means we have to come to terms with kind of recognizing our own flaws or appreciating people for them or not striving for perfection, I think. There's a lot of important issues here that probably need to be addressed that probably won't be for most of us. But yeah, as it says in the paper, relationships between humans and AI should preserve user autonomy and avoid emotional or material dependence. And some of their recommendations are comprehensive research into human AI interaction, restrictions restrictions on human-like elements in AI, protecting user privacy, promoting wide accessibility, and implementing robust controls against misinformation. So yeah. All right, I got kind of a doozy for you. Found this one at the top of the AI breakfast and was like, oh man, if I was still doing those more opinion pieces, I would probably write a whole thing about this. This is fascinating stuff. All right, this one coming out of Harvard and MIT. Automated social science. Language models as scientists and subjects. And it explores how these big, large language models like ChatGPT can simulate social science experiments. That's testing on us, by the way. So they're focused on something, I guess this is pretty common in social science, but it's called a structural causal model, an SCM. It's how you do hypothesis testing in social science experiments in virtual settings. So LLMs ran all these social experiments inside this simulation. So they did things like bargain over a mug to see what price they could get it for, sentencing people to jail, job interviews and auctions, just to see how changing different variables would actually affect the outcome. And the outcome is that they're pretty good at figuring out what's going on if they're given a detailed causal model ahead of time. Now, they were getting pretty good at predicting what people would do. They were also not that good at predicting the magnitude. So they'd be like, that person might be upset, when they were like really upset, or they were really upset and they're like, I would give it probability of a little bit that they're upset. You know, it was off on that emotional resonance, but they were right in the direction. But the cool thing is we now have this whole new way to test these hypotheses that were basically unsimulatable before. It's not like the same kind of simulations you usually run. They have to be language and nuance based. And now LLMs inside these virtual environments let us do that. So who knows what something like this is going to give the social science community to work with. Okay, so here's how their model works. And we should note that each step in this process corresponds to an analogous step in a social scientific process as done by humans. So you come up with this social scenario, then you generate a hypothesis, like they're on a budget, so they'll like accept or deny this deal. You get agent building, so you just like the way you would normally get to probably college students to like do this in a lab, they get the two LLMs to talk to each other with different goals, different mindsets. So they design that interaction, so who's gonna speak in what order, right? And then they can watch that happen over and over again. They get a model estimation. Over time, the buyers usually do buy at a certain price, and then they understand what the best deal that can occur is, or whatever the social scenario is. All that data gets collected, and you can see the experiments running in parallel, and you can just learn from them all. That's crazy. Social science has been upended. So here, experimental design and fitted for a judge is setting bail for a criminal defendant who committed $50,000 in tax fraud. So you see these factors, criminal history, you get a quantitative number there, judge's case count, quantitative number, and defendant's remorse, quantitative number, and then the bail amount. So like your simulation details, the agents, like judges and the defendants, defense attorney, prosecutor, you get the speaking order, judge, prosecutor, judge, and blah, blah, blah. The variable information that you can kind of hone in on over time. What the heck? They're going to figure out some crazy stuff about humans. Then I bet it starts branching back into our evolutionary history and the way society should run. Hopefully that kind of information can actually help us construct better rules and governments. There are different ways to self-govern even. I'm really excited about this automated social science thing. Let me know in the comments below what it is that you would test with this. What if anytime I've ever been to a party and I was just like, why did you say that? Or work setting, I'm like, why did you say that? Like a romantic date, like, why did you say that? Like, what if you would have said this? I'm always simulating things I could have said better and like I feel stupid for saying that, or that thing went well. It's like, and now it's like super nerds. You can just sit at home and be like, simulate all these situations before I go out in public and embarrass myself. Actually, maybe this will be the worst thing ever for incels. All right, so the next project I want to talk about introduces PhysDreamer. Or PhysDreamer. And what this does is it allows 3D objects that are just sitting in 3D virtual environments to interact correctly when they're bumped, hit, scraped, bounced, whatever. So as a superstar team, MIT, Stanford, Columbia, and Cornell, I think, yeah, all of them, all the big schools, they got together to build this system that understands physical material properties of 3D objects. So it has to just kind of learn that stuff like this is pretty much soft and stuff like this is pretty much hard, and this stuff sounds like that when you tap on it. This scrapes really easy. This kind of, if you scraped it, you would rip it and then foam would come out, or whatever this chair is made of. And to train it, instead of teaching it all about physical world properties like the way normally a simulator would be built, they gave it a bunch of video. Just like a kid watching a bunch of video, you can just see what's squishy, what's hard, what scratches, what breaks, what doesn't. But the cool thing is you can feed most of that video into the system to train it, but then you can keep some of it as testing data. Then say you take a hat and you squish it in the system, and then you show it how the hat really squished in real life, and then you have this kind of delta, this difference that you can say, oh, you were close with the flowers and the way they interacted, but you were wrong with the hat, and then you can tune the model even further. So they've been doing that, and at the point where the model is now, people find it pretty realistic. All right, so look at some of these examples of poking an object in a variety of ways to see if they match up with the real video. So you can see the way they can grab the flower with the virtual finger, poke at it, and see the way that it sort of bounces. Very real. I mean, that looks like every time I've just bumped a plant before. So the real capture here on the left of how that phone cord dangles. There's how PhysDreamer compared to PhysGaussian and Dream Gaussian 4D. You can tell it's got the most bounce right there. Oddly, it's like a little more bouncy than the real capture, but it does seem pretty realistic. Let's see how it handles this hat. So here's the real capture of the hat being poked on the left. The real one swings a bit more than any of the other examples, but I would say that PhysDreamer did the best, although PhysGaussian looks pretty good too. But you really notice it when it comes to the flowers. So the real bounce, this footage on the left here, doesn't move nearly that much. And PhysDreamer here does the closest for sure. The Gaussian is like super animated, like send that one to Disney. The next paper, let's talk about AutoCrawlers. Like if you know web crawlers like Google and being used to crawl the internet and read everything that's out there and pull it into their server for analysis so you can search with Bing and Google and find everything. But then you think about what's happening with large language models. You know that they're good at coding, including, you know, web crawlers and, you know, coding things like regexes that would be like perfect for whatever situation you're in. Understanding the structure behind like headers and tags and the various levels of even data packets that go back and forth between a website, and then all of the layers all the way up to the language. And you have to think, what's the next generation web crawler going to look like? Let me introduce you to AutoCrawler. And this is a pretty interesting use case, because I will say that like you can look at some of my oldest videos. I was like, ChatGPT is going to kill Google. Like, it just doesn't make sense. I just don't go look for links the same way anymore. I'm really not going to go just ask some question about physics or biology in the way that I used to and like kind of click around and try to read people's stuff. But maybe instead of actually using a large language model to generate an entire answer, I could see how a really sophisticated web crawler might go out there and find something that is kind of the same thing, but it could be a link to something that a human has written. But not just giving me like a page that like links to some Wikipedia or blog or some obscure manual on some doc website somewhere, but going like right to the point that I need. So traditionally, these are just predefined scripts. I mean, probably super sophisticated, but they're still fragile in the sense that a bunch of humans have put them together and they have all sorts of edge cases they don't really do a great job at. So that's why a tool like AutoCrawler can address this by incorporating a two-stage process that dynamically adjusts to any type of web content. So they're calling it a progressive understanding mechanism. And what it does is it's using large language models to actually read the context of the website to see what it's all about, right? It's not about seeing the HTML. It's about putting the web page together, having someone read it, interpret it, almost visualize it like a human so that it knows what it really is about. And then once it knows that, it can talk back to the web crawler about how to digest this information. Like, what should we copy to our server? How can we reference this in the future in a Google search? So scalability, error reduction, and just basic semantic understanding of like why this was written in the first place is now better incorporated into these web crawlers. So now let's break down the biggest video I've had on this channel in 6 months. I got over 6,000 views on my last video. Guys, girls, mostly guys, according to my analytics, but I'm on cloud 9. Thank you. Look at these metrics: 129 new subscribers, $25 in the bank, 827 watch hours. That curve, that grade down there, that's my average. This is like way above. Look at that, 6,400 views, 130 comments, 96% positive thumbs up, 310 likes. I don't know what to say. I guess I kind of thought this would be a kind of catchy title, GPT-5 leaks. I mean, come on, we all kind of just have to click on that. I guess people are giving me the feedback that like my comedic timing was like on point with this one, but also it's sad that the best engagement I pretty much ever got was when I wasn't talking. But it's really rare for me to keep 50% of people to the 3-minute and 25-second mark. Also, having an average click-through rate of 8.5 is pretty good. As always, most of the traffic's coming in from the browse feature. For people who did find it through search, it was GPT-5 that they were looking for. Although shockingly, nobody clicked on the end screen element, so maybe I did something wrong with that. I don't know if we need like a moment of silence for this or whatever it is, but also, as if all these metrics weren't enough, for the very first time, we didn't have 100% men watch this. There was 0.09% female.
Insane. This is mind-blowing. There is no way. It is just crazy.
I got a couple comments being like, I'm a woman in there. And I was like, well, I know there's like a couple women, but we have to get 0.5 to like round up to 1%, you know? But 0.9, we basically got there. I'd say 1%. So good. I'm glad AI content is resonating with a broader audience. Compared to my last video, a whole lot more people were not subscribed, which is great because that means it's showing it to new people. And it's been so hard for me to get it to show to not subscribe people. So that feels great. 70%. Yeah, US, UK, Germany, Canada, Australia. You know, love you all. Click that end screen. You know, if you watch it this far and like, you know that I'm just struggling to make a living doing this. So if you want to hit the like button, share it somewhere, still means a lot to me. I'm not so big that it's just like whatever. It really does. Thanks for the comments. Thanks for watching. And yeah, we'll see you in the next video.